Hello dear students, we're going to do class 8 physics chapter 5, that is light, so which is in page number 84. Okay, the first topic is refraction of light. So what is refraction? Let's take a simple example. So you can go through your book if you want to. So you take a glass, all right? You take a glass and then you put a coin at the bottom of the glass. Okay, you put a coin at the bottom of the glass, then you move backward. Okay, you move backward, you'll find that the coin is not visible anymore. Okay, so now you ask your friend to pour a water. Now you ask your friend to pour a water in the glass. So you'll be surprised. You will see that this coin is getting refracted. This coin is getting visible. This coin is getting visible from a distance. So why this is happening? This is happening because of refraction of light. Okay? So we can take another example. You put a pencil, okay? You put a pencil in the glass. Okay? So, when you put the pencil in the glass, when you observe from distance, you will find that there is a slight bend, okay? There is a slight bend of the pencil. So this bend is because of refraction of light. But when you take the pencil out, you will find that there is no bend in the pencil. The pencil is straight as it is. Okay. So these are the two examples by which, simple example by which we can understand what is refraction of light. Okay. This phenomenon is happening due to refraction of light. So in class 6 and class 7, in the light chapter, we have already read that light travels in a straight line. Light travels in a straight line. And this phenomenon is happening due to the change of speed. Due to the change of speed from one medium to another medium. So this medium you can see it is air, and the other medium it is water. So when light is traveling from one medium to another medium, what is happening? The phenomenon of refraction is taking place. That means it is getting bent. It is getting bent while traveling from one medium to another medium. Okay. Now, so okay. Now let's see what happens to the light when it enters from one medium to another medium. So, okay. First, when the light is entering from optically denser medium to optically rarer medium, okay? On entering optically denser medium, say for example air to water, okay? The speed will slow down. When it is entering to optically denser medium, the speed of light will slow down. Oppositely, what is happening when it is entering in the optically rarer medium, okay, from denser medium to rarer medium, what will happen? The speed of the light will increase, okay? So, now let's try to understand the terms. Okay, now let's try to understand some of the terms related to refraction. Okay. First, you can see in your book, first is the incident ray. So what is incident ray? So we have taken two medium. It's air and the other medium is glass. All right? So when the light is traveling which falls on the boundary between the air and the glass. Okay? This particular ray is known as the incident ray. Okay? And the next is the reflected ray. So what happens, as we know that the light ray will not travel in its original path. It will get deviated when it is traveling from one medium to another medium. So this particular dot line, it is supposed to be the original path of the light, but it gets deviated. So which is known as the reflected ray. Okay? Okay. The third point is point of incident. Point of incident. So we can see in your book, you can see O, which is at the boundary between the air and the glass. Okay? Which is separating the air and the glass, which is separating the two medium. So this particular point where the incident ray goes and strikes, this is known as the point of incident. Okay? Next is normal. So what is normal? We can see the line NP. This particular line NP, it is the perpendicular line. It is the perpendicular line drawn between A and B. This particular imaginary line is known as the normal. And the next point is angle of incident. So angle of incident, it is denoted by I. So we can say the angle between the incident ray and the normal. The angle between the incident ray and the normal, it is known as the angle of incident, or diangle X, O, and N. X, O, and N, this particular angle is known as the angle of incident. So next is angle of reflection. Angle of refraction, it is denoted by letter, small letter r. So now again we can see diangle Y, O, and P. Which angle? Y, O, and P. This particular angle, it is the angle of reflection, or else we can say the angle between the normal and the reflected ray. The angle between the normal and the reflected ray is the angle of refraction. Okay? So these are some of the terms that we have to learn. So next is laws of refraction. So there are basically two laws in refraction. The first law says the incident ray, the normal, the incident ray, the normal, and the reflected ray, it will all lie in the same plane. Okay? These three, angle of incident ray, normal, and the point of incident, and the normal, this all will lie in the same plane. And the second law says so the second law is based on the pair of media through which the light undergoes reflection. The pair of media in the sense it can be air and water, or it can be air and glass, or some other medium. So, as we have already discussed that when a light travels from one medium to another medium, it gets refracted. Okay? So, what does the second law says? It is the ratio. It is the ratio of sine of angle of incident. Sine of angle of incident to the sine of angle of reflection, which is also known as refractive index. Okay? So, we can say that it is represented by mu. We can say that sine of angle of incident by sine of angle of refraction, it is constant. Okay? It is constant. This is the second law. Okay? The ratio of sine of angle of incidence to the angle of sine of reflection is always constant. This is also known as refractive index. Okay? The next topic is refractive index. We are going directly there. So this is also known as refractive index. It is represented by mu. Okay. Okay, in refractive index, there is a formula in refractive index. Refractive index is represented by mu. So what does it say? It says, the refractive index says, it is a ratio of speed of light in vacuum by the speed of light in a medium. So, refractive index is represented by mu. This particular sign is mu. So, what does it say? It is the speed of light in vacuum. Vacuum means air. By the speed of light in a medium. So, medium can be anything. It can be water, alcohol, glass, diamond, whatever the medium may be. But by this, we can find out the refractive index of a medium. Okay? Okay, next we are going to see the properties of refraction. The properties of refraction. So first, okay, again we are going to take two medium, that is air and glass. Okay, air and glass. So air is optically rarer medium than glass. Okay, so what happens? So first we are going to do normal. So when the light is traveling from optically rarer medium to optically denser medium, what will happen to the light? What will happen to the path? So this is the incident ray. So this is the incident ray. So what will happen? So normally at this angle, it should travel at this path. It should travel at this particular path. But due to refraction, the path will get bent, the light will get bent. And when the light is traveling from optically rarer medium to optically denser medium, the light will bend towards the normal. Okay, remember this. When the light is traveling from optically rarer medium to optically denser medium, it will move towards the normal. Okay, it will move towards the normal when it is traveling from optically rarer medium to optically denser medium. Okay. Now let's see what will happen when light is traveling from optically denser medium to optically rarer medium. Don't disturb. Okay. Okay, next, we'll see when the light is traveling from optically denser medium to optically rarer medium. So first, the angle of incident. This is the incident ray. This is the normal. So again, this is supposed to be the real path. But what happens here, when it is traveling from denser medium to rarer medium, it will deviate from the normal. Okay? It will move from the normal. Okay, we have seen when it is traveling from rarer medium to denser medium, it is moving towards the normal. The path is moving towards the normal. But when it is traveling from optically denser medium to rarer medium, it is moving away from the normal. Okay? So, next we'll see if the light is traveling straight. Okay? When the light is traveling straight at 90 degrees. So, in this case, what will happen? It will not suffer any refraction. It will not suffer any refraction. Refraction will be 0. Okay? It will be 0. When it is at 90 degrees, it will not suffer any refraction. The refraction will be 0. Okay. Now the next topic, let's see, it is effects of refraction. So in the earlier topic, we have seen so now again we'll take a glass. Okay, we'll take a glass and we'll pour a water in it. Okay, so we'll put a water in the glass, so we can see that this is air and this is water. Okay, so now we'll put the pencil again. So we'll put the pencil. As we put the pencil in the water, we can see in the boundary between the air and the water, the pencil gets bent. Okay, it is getting bent. Okay, this effect is happening because of refraction. Because of refraction. Another example we can say. Another simple example. If we put a coin, if we put the coin at the bottom of the glass, okay, due to refraction, we'll find that the cup point is somewhere on the top, visible on the top. Okay? This is happening again because of refraction. Okay, the other topics we'll discuss in the later class. Thank you.